Hello everyone, and welcome to our lesson on 6.6, which is about inequalities in two triangles. Our last lesson was inequalities in one triangle, where we compared the sides and angles to each other. Now we're going to do that, but we're going to do it across two triangles. Our warm-up question today was if you could add any feature to your dream home, what would it be? Mine would be one of those secret passageways behind a bookshelf. Love books, and I just think that'd be really cool. All right, so the hinge theorem states. The hinge theorem states that if you have two sides of a triangle that are congruent to two sides of another triangle, so let's mark that first. AB is congruent to DE, those marks. AC is congruent to DF. Okay, so we've got two sides of one triangle congruent to two sides of another triangle, but the included angle of the first triangle, angle A, is larger than the included angle of the second triangle. So the way I'm going to do that is I'm going to mark that these are different, and it says that it's larger. So let's go ahead and just assign a numeric value just to show you this. This looks like it might be about 110 degrees, whereas this looks a little bit closer to like maybe 88. I'm just putting random numbers on there. So 110 is greater than 88. You could see that these two same amounts, you could do this with your hands. As you open up your hands more, the space between them gets greater. As you close your hands more, the space between your fingers gets less, it's smaller. And so what this is saying is the side opposite, so if I look across from that, the side opposite that angle is going to be longer in the first triangle than it is in this second triangle. So here's what that tells us. That tells us that BC is going to be greater than EF. BC is going to be greater than EF, and we know that because 110 is opened wider than the 88 degree. Angle A is larger than angle D, and so side BC is going to be greater than side EF. Okay, so what is the converse of that? You just go backwards. It says if you still know the two sides of one triangle are congruent to the two sides of another triangle, so this must exist in order to compare. And you know that let's see, how do they phrase it? They say the included angle of the first side is larger than the side of the opposite. Okay, here we go. And the side opposite the included angle of the first is larger than the side opposite the included angle of the second. That's like a mouthful to say, but here's what it's saying. If you know for sure that BC is longer than EF, if you are given, so let's go ahead and put some marks on it just to show you. If you know, I'm going to put 3 here, I'm going to put 4 here just to show it's different. If you know that this is larger, so let's assign a number to it. So like maybe this was 10 and this was 8. If you know that, that must mean that this angle, the angle across from it, is opened up wider. The included angle of the first triangle is going to be greater than the included angle of the second triangle. So what that means is that this angle A, the measure of angle A, is going to be greater than the measure of angle D. And so you can tell this one, if it's like an alligator's mouth, it has its mouth opened wider in the first triangle than it does in the second triangle. Okay, so this is going to be where the two sides are congruent, but the angles in between are not congruent. So that is the hinge theorem. I kind of think about it like a doorway. If I think about the teacher that teaches next to me, we both have the same size doors. It's like a standard school door. And so we also both have the same door frame. And so because that door has to fit in that frame, it's a little bit longer. But sometimes he'll prop his door open, whereas I have mine usually just barely propped open. So the space in between his door and his door frame is going to be a lot bigger than mine because I always have mine propped more closed. So that angle is going to be smaller, when that means that that side is going to be smaller as well. So very similar to our lesson yesterday, we're just doing this in two triangles. So it says use the hinge theorem. So first of all, we need to make sure we can use the hinge theorem, but to compare the sides or angles. So the first thing we need to do when we're looking at these is check and make sure I can use it, that I do have those two congruent sides. So what I pay attention to here is I have a 15 and a 9. What I pay attention to here is that I also have a 15 and a 9. So I do have two sides that are going to be congruent, so I can add my markings if I wanted to. 15 and the 9. But the angles in between, you know what, let me change that color coding. I think this will help you all a little bit better to show that those are two different triangles. Here we go. There's the pink triangle and there's the blue triangle. I'll make it easier to talk about. In the pink triangle, I have a 79-degree angle that's included. Included meaning it's sandwiched in between. But in the blue triangle, that angle is 74 degrees. So the one that is larger, 79 degrees, is more than 74 degrees. And so that means that this side, LK or KL, is going to be greater than PM. KL is going to be greater than PM because this is 79 degrees, whereas this one only opens up 74 degrees. So this side PM is going to be less than KL. Okay, so let's first make sure we can use the hinge theorem again. I have a 24 and I have a 24 in the other triangle. And then these are actually overlapped at a side. Remember from previous lessons that this is the reflexive property. They would both overlap right here in the middle. And so that's the reflexive property. And so I can add a marking there to show, hey, those are also congruent to each other. And so now I can use the hinge theorem. The hinge theorem states that when I look at this, I have a 59 degree included angle here, but a 65 included angle here. And so that must mean that if I go and I look at the 65 degree angle, the side across from that is going to be longer than the side across from the 59 degree angle. So that must mean that CB, side CB, is going to be greater than side AD. Side BC is going to be greater than AD. Okay, let's look at the next one. Let's keep color coding. These are broken apart, so I know I'm not going to be using the reflexive property here. I've got 16 and 25 in the blue triangle. I also have 16 and 25 in the pink triangle. So let's compare the included angles, angle D and angle H, which is kind of what they're doing here. That's angle GHI, still that yellow angle, and angle FDE, which is still that yellow angle. So how do they compare? So this is actually the converse. What we're given here is we are given that GI is 33, whereas FE is 35. So which one is bigger? 35. And so what that must mean is the angle across from it must be greater. And so that would mean that the measure of angle FDE is going to be bigger because 35 is greater than 33. So I know that that angle measure must be greater as well. Okay. Let's see. We've got our, can we use the hinge theorem? We have a side and a side, congruent to a side and a side, another triangle. Okay, again, this is the converse. I know because I'm making decisions about angles instead of making decisions about sides. So there's my included angle. This one opens up to 18, while this included angle opens up to 18.5. Which one is greater? Obviously the 18.5. So that must mean that this angle, the measure of angle DEB, must be greater than the measure of angle CAB. My encouragement is if you are doing the video, pause it and try these real quick, and then click play to see how you do. So again, these overlap. So let's see. I want to use, this has a side marked congruent to this side, but again, this is going to be the reflexive property. So I've got this side and this side are going to be the same as this side and this side. And so I get to use the reflexive property to mark that in the picture. Okay. And then the included angles sit between those sides. So let me highlight that. Here's an included angle that's 32. Here's an included angle that's 28. So which one is larger? It's usually easier for me to look at the larger amount. The larger one is going to be the 32. So the side that falls across from that, DC, this side right here, must be greater than BC, the side that lies across from this one, because we know that 32 is greater than 28. So that crocodile would have its mouth open a little bit more, and so the distance between its teeth would be greater. Okay. All right. We have 7 and overlap at QS. Again, this is going to be an overlap, so this is the reflexive property. So I get to add my congruence marks here. So I do have two sides of one triangle congruent to two sides of another triangle. So I get to compare their included angles. One opens to 5.3, one opens to 5.1. So which angle must be larger? The angle across from the larger side, which is going to be angle PQS. PQS would have to be greater because 5.3 is greater than 5.1. So this star angle would have to be a little bit bigger, not much. You can tell because these values are so close, but it's going to be a little bit bigger than the measure of angle RQS. Okay, it looks like I have another reflexive property here. I've got 6. Okay, 6, and then let's see, 6, and this is a reflexive property, and then 6, and then the reflexive property. These overlap right here in the middle. So I do have two sides of one triangle congruent to two sides of the other. So I am allowed to use the hinge theorem to make decisions about the third side. Okay, let's see. So what does that mean? That means that this third side that lies across from the 53-degree angle, how does that relate to the side that lies across from the 57-degree angle? 57 is greater than 53, so that must mean that NM is going to be greater than KL. This third side is going to be greater than KL in the picture because 57 is greater. Okay, this is our last one like this. We have a side of 12 and then the reflexive property, and then a side of 12 and then the reflexive property. So I'm going to add those marks just to remind you where those come from. And so we're going to be looking at our included angle. Why do I highlight those and mark those up every time? Because that helps me find my included angle, and that helps me pay attention. There's a lot of numbers in this picture. There's a lot of letters in this picture. That helps me pay attention and kind of narrow in on the hinge theorem. We're trying to make decisions about these two angles, the included angles, based on what they open up to. So this one opens up to 9, whereas this one opens up to 10. So obviously that side length is longer, which means that that angle is going to be greater in this one. Angle EGF is going to be greater. So that's just using the hinge theorem to make decisions about angles or sides in two triangles. The only other thing we're going to look at today is determining the range of possible values for x whenever we're looking at two triangles. And so this is going to be 2 parts. I'll probably do 2 of these and then just set up the others and put the answers because this does take a little bit longer. But we're going to look at this and determine a range of possible values. So let's do the same thing. Let's color code it how we did before. So blue and blue, and then pink and pink. So I can, in fact, use the hinge theorem because I've got 2 sides of one triangle congruent to 2 sides of another triangle. So we're going to be making decisions about these included angles right here. So one of them is 45 and one of them is 6z minus 3. So our goal here is to write an inequality based on the fact that this one opens to 25, but this one only opens to 24. So which one is greater? 25. So what does that mean about this angle right here? That angle is going to be greater than, 45 is going to be greater than 6z minus 3. But we also have to remember that in order for this to be an angle, if this is smaller, this dot angle is smaller. I'm going to put a little dot there. In order for that dot angle to be an angle, it actually has to open up more than 0 degrees. So we're going to do 2 things. We're going to make sure it's less than 45, but we're also going to make sure that it's greater than 0, because if that's equal to 0, that does not create an angle of a triangle, and thus we could not use the hinge theorem. So we're going to work this in 2 parts. We're going to add 3 to both sides. And so 48 is greater than 6z. We divide by 6 on both sides, and we get 8 is greater than z. So that means that z has to be less than 8. But in order for it to be an angle, it also has to be greater than, when I do this, I get 3, divide by 6 on both sides, and that's 1/2 or 0.5. So the range of values for z, remember we like to put this together, the range of values for z is going to be greater than 1/2, and it has to be smaller than 8. So if z was anything outside of that range, here we go. Oh, goodness, that was the wrong thing, y'all. I'm so sorry. If z was anything outside of this range, then this would not work. So z and 8. So when we're looking at this, we want z to be greater than 1/2, but smaller than 8. Okay, let's do that again. Let's do that with this problem right here. Let's check and see, can we use the hinge theorem? So these triangles are separated, so I'm not going to have to use the reflexive property. And we're going to make decisions about the angles, the included angle. I'm going to go ahead and write myself a note, because if not, I miss this every time, that this is a 90-degree angle. And so we're making comparisons. So this one opens up, that very first triangle opens up to 7, while that second triangle opens up to 9. So which one is greater? The 9, which means that 90, that angle, is going to be greater than 3x plus 18. This dot angle right here. So the 90 has to be greater than 3x plus 18. But remember, we also have to say, so I'm going to say, and that dot angle, 3x plus 18, for it to be an angle, has to be greater than 0. So again, I'm just going to solve this. I'm going to subtract 18 from both sides. I get 72 is greater than 3x. So I know that I'm going to get x is going to be less than 24. X is less than 24. Okay. But I also have to remember that for this to be an angle, I'm going to subtract 18 from both sides. I get negative 18. Divide by 3 on both sides, I get negative 6. So x is going to have to be less than negative 6. So x is going to have to be bigger than negative 6, but smaller than 24. That's my range of values. So I will set these last 2 up for you, and then I'll put the answer. That is really the hardest part. Y'all have gotten pretty good at doing the algebra work. If not, you can watch some of my other algebra videos to get some help. But these last two we're just simply going to set up. This is going to be a reflexive property problem, so we do get to add that side right here. And so I'm comparing angles right here and here. I kind of wrote all over that one, so I'm going to darken this and make that 60. Gosh, you still can't see that. 60. Okay, I'm just going to do this, 60. And so I'm comparing 60 and 5x minus 20. This one opens to 15, while this one only opens to 10. I'm a creature of habit, so I like to say, okay, that means that 60, this star angle, is going to be greater than 5x minus 20, this dot angle. But remember that this dot angle, 5x minus 20, also has to be greater than 0. So remember that is a two-part inequality. And so when you solve this one, you can try this on your own. You end up getting that x is greater than 4, but less than 16. That's my range of values. And then this last one, again, side, side. It's congruent to a side and a side. I'm going to write myself a note that this is in fact 90. And so I'm going to be making comparisons between this angle 90 and then this angle 4x minus 8. So I get to use the hinge theorem. I get to go across and say, okay, well, which side is longer? This one opens up more. It's at 10. So I know that 90 is going to be greater than 4x minus 8. So I'm going to put a star there. That is greater than this dot angle. But in order for that dot angle to exist, then 4x minus 8 also has to be greater than 0. And so if you solve this one, you end up getting that x is greater than 2, but less than 24.5. So I hope that helped. That's the hinge theorem and making inequalities in two triangles. And so your assignment is going to be on the back. This is your 6.6 homework. So try those problems and we will check them in class.